Well, there she is. So I'll spin it around in a minute so you can get a better view and remove some of the probes so you can see the wiring. Yeah, so I first struck it up and it was working fine, but it did have a bit of an annoying buzz to it anyway. Yeah, it was just ripple on the power supply. It doesn't have particularly good ripple rejection. Even putting a stonking great cap in, I didn't get rid of it. Now, the regulator would have done that. However, I elected to not go with the regulator purely because if it fails, then all of a sudden I'm going to bang 18 volts into these little ICs and it'll fry them. And these are obsolete. They're from 1960s. If you go on eBay, they're like 20 plus quid each. I don't want to fry them. So, cheap Chinese regulator, not going in there. At some point in the future, I might knock up a regulator board with an overvoltage shutdown on it. Then I'll put a regulator in. But for now, the good old-fashioned low value resistor and additional capacitor sort of the issue right out. So the scope probe, that's after the resistor. Seems I'm off 5 millivolts per division. Let's crank it up a bit. Let's just bring that down. So that's 2 millivolts per division, so we're going about 4 divisions there. So peak to peak about 8 millivolts. Now if I swing this to the other side of that resistor, come on you go. You can see the difference. 5, 10, nearly 20 millivolts peak to peak. So yeah, and it's quite spiky because it's at 100 hertz. It's got lots of additional harmonics to it, which the ICs didn't seem to filter out very well. So just a good old-fashioned secondary cap, low value resistor. You're not trying to filter out the mains hum, you're just trying to filter out the higher harmonics. So if you look again, you can see, don't worry about that, it's just the other scope probe. You can see there's quite a severe peak to that. Whereas if you put it on this one, you see how it becomes more rounded even if I go up to the... See how it's lost that asymmetrical look to it. That's showing that basically the higher harmonics have been filtered out. So yeah, it forms a low pass filter, gets rid of the higher harmonics, which are what causes that breakthrough. Although it's higher frequencies, the fundamental, it's almost like a AM modulation of 50 hertz. It's not easy to explain, especially with the camera rolling. But anyway, so if I pull that probe off, there, get that out of the way. Let's see if I can turn it a little bit with everything hooked up. So yeah, so that's the speaker outlet wiring. Input wiring is just tucked away nicely here. Again, because I was putting it stuff, I ended up having to rewire the volume pot because I'd annoyingly wired it, so it was the wrong way around because it's upside down, and I had a bit of a brain fart as you do, and wired it the wrong way. So you turned it up to go down, down to go up. Mains wiring is coming in on the power con, just your standard mains rated PVC wire, and then some additional heat shrink tubing over it just for protection. You know, and this is all low voltage stuff down here. Didn't bother putting any 100 nanofarad caps over the rectifier in the end because I forgot, and then I put the wiring in and thought, meh. It probably would have made it a little bit quieter had I done that. Mains earth is nice and solid on a 4mm bolt. You see I just sanded away the paint on the inside of here, used a 100-watt iron to quickly solder an additional bracing wire on, so it's not relying purely on the screws going through the metal, which probably wouldn't have worked. To just earth this out. Bear in mind, this is just if this should never become live, but if, say for instance, this wire frays through and touches on it, at least now it has an earth to blow the fuse. How to actually up the fuse? Put 100 milliamp in it, and it blew after the second time I turned it on, so it's now got an amp in it. But yeah, it sounds lovely. That's the front panel. Ended up using that 50k pot in the end. So if you go on the Elliott Sound Products website, it shows you a thing called law faking. So normally you'd use a logarithmic volume pot. So its response rather than linear is logarithmic, matches more to how your ear works. However, if you're forming a potential divider between a high resistance and a low resistance, as you start changing the value of that potential divider, you say, so for instance, it's 100k and you've got a 10k load on it, it's not till you get sort of right round to the 10k point where all of a sudden you're really starting to get those steep changes. You know, from 100k to 90k, you've still got a big potential divider. As you go around that scale, that ratio of division changes rapidly, and it gives it quite close to a logarithmic response. Anyway, I wanted 100k, it's got 50k. Turns out as well, playing around some values, I could have used more global negative feedback. Now I'd have sorted out those issues on the board, but hey ho, it sounds quite nice as it is, to be honest. It gives it a sort of, it's just got this 60s sound to it. If you hear like certain 60s recordings or old 60s amps, it's got that sound to it, and I like it. So yeah, anyway, that's I see it's got plenty of gain. So yeah, little things, just a little bit of this double-sided sticky tape just helps keep the wires in place. That's what's under these caps, just to keep them down. So a little bit of heat shrink around that leg, definitely needed that because it's perilously close to the bolt that holds the rectifier down. Yeah, and I ended up, I thought I might as well parallel up the windings on the transformer. What voltage did I end up with as the supply voltage post that capacitor? Let's have a look, shall we? Is that in shot? Of course it's not in shot. Let's see if I move the phone. Does that work any better? Oh, if only I had an old cockles jar to put behind that. Would you look at that? So raw DC is, what's that, 9.01, and smooth DC is exactly 9 volts, and I mean exactly. See, it says it wants 9 volts. It's got 9 volts. How's that? Eh? So yeah, anyway, I'm going to come here. I'm going to listen to it for a bit, and yeah, bolt the top back on. I decided to put the flange at the back, that way it comes out over the fuse holder and the power console, so if it falls it doesn't knock them off, and likewise it gives it a nice clean. So if I put that on, of course this is never going to go wrong doing it with one hand with it powered up, isn't it? Nothing could possibly go wrong. What would go wrong? Right, so yeah, that's it from the front. It's just a little square box. And see what I mean, on the back that stops the that lip, stops things, anything drops, it stops it hitting the fuse hole and stuff. Yeah, another thing to notice with this is you cannot, if you ever hook a scope up or something to these, you can't hook your scope earth up to speaker negative, because speaker negative on this is actually plus 9 volts. It's not like those early transistor designs where the positive rail is the class is ground, because the signal input actually connects to ground. When I'm talking about circuit ground, what we'd call 0V. It's the point on the circuit where you reference all lever voltages to. I mean, it's the one that also is tied to main safety earth in this instance. So, because the way the ICs work, there is a small biasing circuit inside them, and it actually draws power from the 9 volt rail, but as the output is AC modulated, it needs to follow the output. So Mullard craftily, the output capacitor, normally you'd find on a capacitor coupled amp, the output capacitor will sit between speaker output and the speaker will connect to 0V, but on this one the speaker connects to plus 9 volts. A small amount of DC, like microamps, is actually drawn through the speakers and goes to that bias circuit, and then the output of the amplifier sits via a capacitor between the output pin and that bias pin. So at AC, it's bootstrapped, and the voltage between those 2 points remains the same. But at DC, it's not. The output is at half VCC, and that bias input is at 9 volts. So of course, if you connected scope probe to plus 9 volts, I mean to the output, you're connecting it to plus 9 volts, and you're then shorting ground to output. For instance, in this case, the ground terminal from the mains is going to the case, which is going to these input connectors. If these were isolated, I'd have tied mains ground to 0V, as you do. It eliminates noise and stuff. And likewise, you know, you'd think, well, you could just tie it to plus 9 volt. Well, you could, until you'd then plug a piece of equipment in which has mains earth tied to the RCA inputs, and then you create an issue where you're shorting VCC to 0V again via those RTAs, so it has to go to 0V rail. So yeah, that's just one worth noting. If you ever find yourself with a couple of TAA300 chips, don't connect your scope probe 0V shield to speaker minus. You got to connect it to 0V chassis of the thing you've built. But anyway, that's enough waffling from me. That's the girl. That's it built. I might put a different volume knob on. This one doesn't quite hold the hole. I didn't actually need to drill in the end anyway because this pot doesn't have that lug on it. A slightly bigger one would hide that, but hey ho, this one I might change this at some point. It's got a detent in it because it was off of a different board which needed the center position to tell you when something was centered basically. But to be honest, it's probably only going to be down there most of the time anyway because it's got so much gain. But anyway, that is the Mullard TAA300 amplifier. We're just picking up random noise here on the output at a minute. Shall we put, so let's see what sort of outputs we're getting. If we put the scope probe on speaker plus, oh yeah, look, we're picking up a lot of noise until we ground it. I need a ground point. Come on. Ground. There you are. So yeah, 4 millivolts, and some of that again is going to be scope noise, mains noise and stuff from having two grounded things plugged into the same mains outlet. But yes, yeah, like I say, it's now, well, especially with that case on, it's literally now, since I put the lid on it, it's now ear to the speaker to hear the hum, whereas before I put that resistor mod in, it was quite loud still. So yeah, anyway, thanks for watching as always, and feel free to come by another time if you just want a bit of geekiness. I'm always up to something. I'm going to try and film more stuff these days, although it looks like I might be getting quite busy with other stuff in the coming months, but it is what it is. Yeah, and always stay crunchy.